So kicking off the afternoon, we've got Peter, who I can just see his slide right here. It says GPON, how is it going? So we'll find out how GPON's going from Peter.
Thanks. Hi all and those online. So my presentation today is going to be talking a bit about the GPON network that we're operating. We've introduced 1 gig plans and there's been a bit of interest out there on how they're going on our network. Then I'm going to talk a bit about the future technology. That's going to be the main part of the presentation. And finally finish up a little bit about network function virtualization and what the roadmap's looking like that for the future on our network. So for those who don't know us, we are based in the Waikato in Taranaki. We've got 8 towns, and as of 9 o'clock this morning, our UFB2 towns were announced, and there's the slide as up on the MB site. So we've got about 12 more. So gigabits. So we launched in 2014 a 1 gigabits down, 20 meg up service to see how it would go on the market. So we've got a bit of experience with that. In October last year, we launched the 1 gig down, 500 meg up plan. So we've gained a bit more experience from that, and lots of people migrating onto that plan. We've also got on our GPON network a 1 gig symmetrical service. That's our 3B business facing service, and it's available for ordering. So what I'm going to talk about first of all is the gig plans on our network. So the highest number of plans that we've got on a single port is 4. We've got about 4 ports, 4 GPON ports with that number on it, and about 7 GPON ports with 3 on it. So a GPON port out of the OLT is 2.5 gig down, and this is some of the data that we're seeing from it. So for the RSPs here, you'll probably be seeing this in your network as well. We're seeing little spikes in the network, but generally our networks are quite lightly loaded. You can see there that 30 megs per second is a typical GPON segment. So we've got plenty of headroom for people to use the speed test use case on their systems to find out what their speeds are. But looking over our network totally, so this is a couple of our more highly loaded GPON network segments. So again, you can see that we suffer spikes on it. The bottom one's got a higher oversubscription ratio. The highest oversubscription ratios we tend to have is about 2.3 times. So that means we've sold about 5 gig of services on our 2.5. So again, very low traffic. These some of these graphs are hourly, and I'll talk a bit about the effect of that in the next slide. So this is the highest one that we've got on our network, and you can see a spike there, about 150 meg. And when we expand that hourly one out to 5 minutes, you can see that we're getting up to about 300 meg. So that's about the highest spike we've seen on the network. I don't actually know why it was Christmas Day evening that spike would come on. Somebody might have got a good Christmas present. But yeah, so very lightly loaded there. When we look at our OLTs, so this is our most heavily loaded OLT, and I don't mind sharing these with you. When you use our self-diagnostic tools for diagnosing faults on the network, this is the sort of data that we present to you, so you can get an instantaneous load on our network to aid in your troubleshooting session. So our uplinks on here, our internal network-to-network interface links are 10 gig, and the OLT's got a 20 gig backplane. So again, 4 gigs about the highest that we see in Hamilton East. So again, very lightly loaded, and the OLT has about 3,000 customers on it. Doesn't grow much more than that because of the way the GPON works and the splitters that we have on our network. So overall, we're working very well. Now, In America, there was a consulting company called Broadband Trends who did a survey of RSPs over there. So these were companies that have been selling 1 gig plans for 2 to 3 years and has had quite a extensive amount of data to pull from. What they're seeing is that only about 10% of the population is taking up the higher speed plans, and on their networks they're seeing very little impact of those plans. A lot of them were saying that they see no detectable traffic, up to about 10%. So again, the 1 gig plans are not imposing all that much stress on our network. One of the things that we also monitor is the upstream-downstream ratio. In years gone by, it may have been 4 times or 6 times. We're now seeing about 10 times. And the implication why I'm showing you this is to do with the technologies that are coming up. So on our GPON network, it's 2.5 gig down, 1.25 gig up. So this is showing that we're very lightly loaded on our upstream bandwidth. So having a look at the new technologies, as demand grows, where's industry taking us? So in the bottom left-hand corner, we've got the technologies that we run now. So that's a GPON network. The speeds I've talked about came out in 2013 and went commercial about 2007. So it's been around for a little while. Then we've got 2 steps going faster. There's the NGPON 1. So the top box there is the 10G network. So that's 10G down, 2.5 up. So where we had a 2-to-1 ratio in the GPON network, for the 10GPON network, you can see it's a 1-to-4 ratio. So that went commercial in 2012. Below it is the XGS GPON. So this is symmetrical GPON and will be 10 gig in upstream and downstream. So trials are available this last year, and we might see a bit of that coming forward. But the one that's of real interest, and we'll be talking about mostly, is the NGPON 2. So this is 40 gig down and 10 gig up. So it went into trial last year, and we expect to see a lot more commercialization of it next year. Going after that, there's the 100 gig technology. So they're using 25 gig optics, and that'll probably be around the end of the decade. And there are some competing thoughts about that, which I'll approach on. Now, for those of you who are not familiar with GPON technologies, it's a time division type technology. All the packets get serialized one after the other in a downstream direction. Uses a single fiber, different frequencies going down, 1490 nanometers versus 1310 nanometers up. All the ONTs get the traffic, they pick out which one they want, and the scheduler in the OLT determines who talks when in the upstream direction. So very similar to DOCSIS and WiMAX and all those protocols. The roadside cabinet has a power splitter in it. So its power splitter means it divides the power. So every time you split into 2, you're losing about 3 dB of power going up there. So nothing between the OLT and in the home is powered, as in requires an energy source, and hence the PON, passive optical network. So that's our time division 1. So when we come into the 40G PON, how does that all fit together? Again, we've got the similar sort of technologies as in the GPON. We have a 10 gig wavelength there, 2.5 up or 10 gig up through a power splitter and out into the premises. What 40G PON does is it adds another 3 wavelengths, 4 total, so that you actually have 4 effective PON networks over the same sort of splitter. There's no change out in the roadside cabinets. We just add these over the top. There is a splitter in the central office, which is a wavelength splitter. So because we're operating 4 separate wavelengths, this gives us the ability to optimize each of those wavelengths for a different purpose. So the green one there, I've said, well, it could be for your mobile front haul. The yellow one could be for emergency services, so we could keep a very low subscription ratio on that. Then your priority users or residential users. There's lots of avenues on there, particularly useful for vertically integrated companies being able to separate these sorts of traffics out. So the GPON 2 is actually made up of 2 different segments. So I've just talked about the time and wavelength division multiplexing PON, which has got 4, but has the ability to go up to 8 wavelengths of those different rates. Good for general Ethernet services, but it also carries a number of point-to-point services. So these are designed for very low latency, excellent for mobile front haul, because it doesn't suffer from any of the scheduler delays, particularly in the upstream direction, from the OLTs. The flexible number of channels, but it for workable up to 8 frequencies reserved. Again, a variety of symmetric options on there. And very good for, as I say, mobile and wavelength services. So how does all this fit together? One of the big things with the carriers is that we want to keep reusing our old equipment and sweat them as long as possible when we bring these new ones in. So this is a wavelength plan. So on the left-hand side is the single mode fibre cut-off. We can't use further down from there. And in the middle there's the water peaks. So that's a high attenuation part of the spectrum that we really try to avoid. So we introduce on top of that RF overlay. So this is a legacy system where we take the radio frequency signals, good for cable TV type services, and put them over the fibre. We have to reserve this frequency in UFB1, but nobody's taking it up, and IPTV seems to be the more progressive technology going forward. We also have part of the spectrum reserved for optical time domain reflectometry. So this is where we use test equipment and uses 1625 nanometers. So we push a quick burst of light into the fibre, and judging by the reflection we get back, we can tell the attenuation and breaks and connectors and all that sort of thing. Very good for diagnostics because, I'll go on to the next thing. So our GPON networks are quite a way away from that. So in our network, for example, we can put an OTDR onto a user's premises, look up the fibre without having any destructive effect on the payload services that are operating over that fibre. So we've got the GPON services that we run now, and that's pretty much the wavelength plan that we operate in ultra-fast fibre. We introduce on top of that the 10 GPON networks. So you can see that's on the far left-hand side for the upstream and for the downstream. So we can operate these 2 services in parallel over the same power splitter without having to do anything on the roadside cabinet. We just go and attach a 10G ONT in the user's premises, and away they go. We can now introduce 40 gig services. So there is the upstream and the downstream. So again, they're all mutually separated, so we can operate all these services in parallel over the same power splitter. Now you would have seen in November last year, there's a bit of hype in the media about OpenReach, and there's another company that escapes me at the moment, offering 52.5 gig into a single premises. And this is how they did it. They had 4 wavelengths of 10 gig each from the 40 gig GPON. They added to that the 10 gig service and the 2.5. So that adds up to 52.5 gig into a single premises. You need another splitter in there to run all these things in parallel, but it's certainly quite possible. But we've got more. We've got all the point-to-point wavelengths. So they all sit on the top there and again operate over the same power splitter and infrastructure on the roadside without any change. So we've now got 40 plus 40 plus 10 plus 2.5 going out to our premises. But if we go to the full allocation of the spectrum, that 40 gig could become 80 gig. We could have 80 gig of point-to-point services, plus 10, plus 2.5. So it's 172.5 gig going into single premises. So yeah, I think we're going to be right for a high-definition TV in the future. If you don't want to deploy RF overlay and NG-PON and so forth, there is the opportunity to use that whole upper spectrum for point-to-point services over these the PON network. So again, it becomes quite flexible. Of course, we have a few guard bands just to keep things separated, but that will be the future spectrum. So it gives a lot of life in our current infrastructure, and certainly what I'm hearing from other utilities is that the GPON network, as shown in our network, is really not being stretched at the moment. There's plenty of room to grow with that. So how do we implement it? So there's the 40 GPON as was shown before, and we can just add another combiner and introduce the GPON and the 10 GPON over the top of it. Now you can see there that I've got another splitter on the output of the 10 GPON network. It's particularly going to be important on a network like ours because in our network we divide the towns up into cabinet serving areas which have about 144 to 180 premises in each one. So you're not going to have great demands for 10 GPON out there. So I would expect a hierarchical splitter where you would have that 10 GPON split out against multiple cabinets to serve 10 GPON for the few customers in each area that you want. So what's the benefits of NG-PON2? Some really great things. First of all, for load balancing. The optics in the ONT are tunable, and they're tunable on demand from the central office. So that means we can move customers from wavelength to wavelengths. So this is great for load balancing. If we've got a highly congested wavelength, we can move a customer from one wavelength to another wavelength on demand from by configuration. It happens very quickly, and there's no truck roll to go out to either the roadside or the customer premises. It also means for where you've operating your OLTs off batteries, like an active cabinet on the roadside, if you've got a power failure there, you can move customers off one or two wavelengths and combine them onto other wavelengths, turn off those OLT ports and save your battery life. Sure, people get a degraded service because congestion is higher, but at least they have service and they can continue on. It also means that we could have overnight sleep modes where, again, we can move customers onto single wavelengths just to conserve power. One of the great things for me is that I'll be able to do maintenance on this. So all the ports on the OLT do not have to be on the same OLT. So I can now have my 4 wavelengths spread across 4 OLTs. So I can take one OLT out for maintenance or for a sudden fault. All the customers can be shifted across to another wavelength without any noticeable drop of service bandwidth being available. So it provides a far more resilient service to the customers. I can have multiple vendors on one fibre, so I can be using different vendors on different wavelengths because they're all quite independent. Pay as you grow. So I might deploy this one 40 gig wavelength initially, and then as customers grow, I'll add a second one and I'll move my customers around. So I don't have to put in the full 40 gig at one time. Wavelength bonding is where for a customer that requires more than 10 gig, I can use multiple wavelengths into the same ONT, so I can get more than 10 gig. Now the 10 gig is can be degraded if you switch on forward error correction on the layer 1, and we take about a 12.5% hit. So if a customer wants a 10 gig channel and we need forward error correction on, we actually need 2 wavelengths for that. The technology is great for other technologies like mobile backhaul or G.fast. So G.fast is very short length DSL type technologies. It's not compatible with DSL, but it provides very high capacity backhaul. And one of the things that it does offer is the ability to offer wavelengths per RSP. Now, I'm just putting that out there. I don't know how that will play out in the New Zealand market, but we could separate out such that as part of the unbundling, we could offer a wavelength per RSP, and they could drive it into their own splitter. Again, just food for thought. So how does this work? So this is a demonstration that I saw from Calix. So there is their Gigacenter ONTs. They're 10 gig ONTs. The one on the right with the white light is operating on the 10 gig wavelength. And the three on the left are operating on the 40 gig wavelength. And the colours on the back indicate which wavelength the ONT is operating on. So what the guy did was he walked up to the OLT, he pulled out the fibre from the red wavelength port and caused a failure. Immediately that ONT switched over to the blue wavelength and carried on operating. When I've seen this demonstrated, to switch wavelengths while watching a video, I couldn't quite time it, but it's sort of in the order of a quarter or a third of a second. So as you're watching a video, there's a short stutter, but things just carry on. So it's a great technology, and look forward to playing with it as it becomes more available. Now the ONTs that are going to be available, these are ONTs for GPON, so this is the current technology we have. The Broadband Forum will certify interop between them. So all these ONTs should be able to work on the same OLT. You don't have to be vendor specific. Unfortunately, the OLT vendors don't play this game, and there's no certification for OLTs. It may change in course. For the 10 GPON, FSAN, Full Service Access Network group, and BBF are doing the interop plan. But for the 40 GPON, ITU have come into the game and working with the group to define the 40G standards. So there are some issues, of course, with these technologies. Because they're tunable ONTs, the ONTs can drift, become uncalibrated, and move across the frequencies. We need to handle that. Rogue ONTs, this is ONTs where the transmit will remain on and become uncontrollable. How are these going to be handled on the 40G network? Unassociated ONTs, if they can switch networks, when a customer gets deleted, the ONT may become unassociated, so it has no wavelength. We need ways to deal with that. Issues between OLTs and channels, I understand there still needs to be some finalisation work to be done on that. Of course, ONTs receiving and transmitting on the wrong channel will be an issue, and particularly if it's on an unbundled type service. And if we do go to a multi-service provider environment, how do we stop the unauthorized capturing of ONT? That is, you're on the red frequency and you're able to grab one on the blue frequency, or it moves across to you because of fibre break. How are all those things going to be worked through? So still some issues, but overall, a great technology. Some other things that I've read about in the literature, there's a 320 GPON technology, which is just really combining more 10G channels. There's also a 25G TDM. So this is a single frequency with fixed wavelength optics, but it looks interesting because the optics are fairly cheap. So per OLT, you can see that they're double the cost of the symmetric 10 GPON, but significantly cheaper than the 40 GPON. But when you break it down onto a per 10 gig capability, you can see they become cheaper. And they certainly become much cheaper when you talk about the ONTs. So the ITU started working on the 25 gig optics, I think, last year. So that's another technology to watch. So the last part is the OLT virtualization. So I haven't seen any thing come out definitive about this, but Huawei are meant to be delivering this technology in this quarter or next quarter of this year. So what we do here is similar to what you see on a server. We divide the OLT up into virtual OLTs. So we define a port to a virtual OLT. They don't have to be continuous. There is talk about virtualizing it down to the ONT level so that you can have multiple ONTs on a single wavelength or fiber split across virtual OLTs. I'm not sure about the benefit of that because with virtual OLTs on a port basis, you then get control of the DBA and the upstream scheduling function. So this will allow you to, in a vertical integrated market, which is where I believe it's come from, assign different virtual OLTs to different services, and there's some examples there. In our environment, it could be, and this is only a postulation, is that different RSPs could have a rent space on an OLT. So how would this work? For the access operator, we would provide, set up the virtual OLTs, create VLANing and a few other common elements. But each virtual ISP would then be responsible for their own assurance management, for their own service provisioning, and other management functions. So interesting technology. Next year I'll be hopefully able to talk to you much more about it. Don't know how it will be configured. The network element manager from Hawaii is quite expensive, but I have seen some discussions about using OpenFlow or something like that technology onto these virtual OLTs. So that's the quick look at GPON on the ultra-fast network and where we're going in the technology space. Any questions?
You mentioned mobile front haul. Have
Yeah.
you tried that on your network with anyone?
No, we haven't yet. I don't know how it would operate. It's just what they're proposing to make it available to work with.
Could you just repeat the question?
Oh, sorry. Yes. The question was: have we worked with mobile front haul on our network and tested it out? So the short answer is no.
When you're talking about virtualizing the OLT,
Yes.
allowing RSPs more control, would you also entertain a competing bitstream wholesaler buying a frequency from you and also dealing with RSPs?
I think this is a question about how we're going to commoditize and productize this rather. Not sure about this. We're just interested to know this technology is coming. And we're also very aware that in 2020 we have to unbundle. So I don't know whether this would come under the equivalence of input regime that we're required to operate under. We're just putting it out there to really start the discussion. So, sorry, I forgot to repeat the question. It was really about how we would have competing RSPs and so forth operating on our network. So there's one over here. Yep.
What about virtualizing the ONT?
How virtualizing the ONT with regards to NFV. There's a few things happening there. The next Broadband Forum is working on an upgrade to the TR069 standard, which will allow us to offer 069 into separate domains on the ONT. So part of the problem we have now if we offer it is that anyone that comes on with 069 will be able to control any part of the ONT, including that from other RSPs. So we've been very reticent to make that available. So that's one part of it. There is virtual CPE technologies out there such that a lot of the RGW functions and what we provide on the ONT could be pulled back further up onto the upstream side of our network to provide a lot of the firewalling and virtualization functions up there. So I'm not sure how that will play out. Certainly some of the ONTs now allow us to put our own software packages on that, yet to play in that space. Hi.
Do you, now that you're a few years in, do you think we did anything wrong with the physical deployments in UFB, or do you think this is showing that this has got a lot of future?
Did we do anything wrong with the physical deployment of yeah, from inside the Guy network, there are a few things that I would like to have done differently, but I think that's same with any build. No, we've completed our build, and our crews have gone off to Australia or wherever. So no, we're delivering these technologies out there. So fundamentally, no, I think we've done a pretty good job of that.
We picked the right fan-out ratios, put the splitters in the right places,
Different LFCs put splitters in different places. Some operate more distributed hierarchy. We've tried to keep the splitters all in one place in the roadside cabinets. Not to say that we probably may not in the future put, particularly with the 10G network, putting splitters up in the COs for the faster technologies. With unbundling, of course, that then becomes a different ball game because the service provider can do their own design on that, and we just provide the underlying fibre. So there's a question right at the back behind the light, yeah?
You touched on it a bit in your presentation about the impact that like a rogue ONT can cause, or perhaps a deliberate attempt to sabotage the network. I'm just wondering, do you think that, like you mentioned with the 40 gig service, you might be backhauling a cell site or whatever, some sort of more critical services where uptime will be important, probably more so than a residential connection. Especially since you're saying putting a splitter in the CO with then additional splitters, roadside cabinets, etc. One rogue ONT that's drifted to another wavelength or whatever could have quite significant impact. Is that something that sort of would be an issue for perhaps it's the wrong design to choose for those sorts of sites?
Okay, so the question's about whether a PON network generally is the right sort of technology for these sites. I'm not going to make that call in that I'm going to say, as an access network, if you want to put a mobile site out there, we can provide you GPON type technology, we can provide you a bitstream technology, or we can provide you dark fibre. We're going to provide you a smorgasbord, and you take what's necessary to assure your security requirements. Yes, another one behind the light, yeah?
Yeah, in front of the light. There was a question about virtual CPE type things and so on. I remember one of there was a point in the original UFB thing about doing wireless backhaul to an ONT from an RGW. Has there been any thought to being able to put a standard access point built into a ONT so that you don't have to put an RGW at all?
Yeah, there has been a bit of debate on that. First of all, in our price list, we do offer, there is provision for a Wi-Fi type service, so we could provide a layer 1 Wi-Fi product. It's never been prototyped, and I haven't had a single request for it.
The intent of that is for Wi-Fi backhaul from an RGW.
Yes, sorry. So the question's about wireless backhaul to it, to the ONT. Yes, we can certainly have a look at that. There are restrictions that we can only play in the layer 2 space We can't provide layer 3 type functionality, so netting and DHCP down on the RGW is outside of where we're allowed to play. So certainly we can provide wireless back interface with the ONTs. Some of the ONTs have Zigbee and those sorts of functionality onto it. So we're not just restricted of what we have today. So certainly that's something that we can develop.
What does the wireless controllers or whatever in those things, does it support, would it support, connecting, a house of laptops to it as though, or, whatever it was, instead of, and so not just for ONT backhaul, RGW backhaul?
Now, I'm not quite sure where you're going with this. The ONTs themselves that we use have got RGW features inside them. We just turn them off because we're not allowed to play in that layer. But yeah, certainly the ONTs can provide all that and do away with the RGW. And I know there's one RSP that talked about not having RGWs, they just provide untagged services. And the RSP and the homeowner just wire it up as they want. Anything else? Yes, sir. Have we tested any of the SFP-based ONTs? Not yet, but the purchase order is imminent. Look, so these are ONTs that just come on an SFP, and the idea is we just plug them into a normal switch. Very good for things like CCTV cameras around streets and that sort of thing. We don't need full RGW. The contract with CFH requires us to always provide 4 ports and 2 voice ports, but we have talked about providing dispensations for things like CCTV, and they are open to those discussions.